If you've not yet put up your phone, if you could please go do that now, that would be grand. Thank you very much. Oh, if it's in your locker, that's fine. You can just, yeah. Okay, and I need to pull this up and go to Science 9 because you don't want to be doing. So what I'm going to have you do today is we are going to go to 1.3F, which is on page 60. And you're going to write a detailed story about what you think happened in the little cartoon that's going on there, okay? And then you're going to go on to pages 61 and 62. And you're going to read and follow the instructions and write down anything that you need to write down. And then we're going to debrief on it together, okay? So, while you're doing that, I'm going to check your homework. This is for block 4 because I forgot to check their homework last day. Okay, but you guys, it's just 20, 21, and 22. But so I'll come and check that while you guys are doing some observing and inferring, writing a little story, okay? Just be creative, do whatever, write whatever you want to about what you think happened in that little picture, okay? All right. So that's page 60, 61, and 62. Close? Okay, I'll take close. Anyone confused about what you're doing on page 60? I'm happy to help you out if you need it. I might not have enough for the whole class, but if you don't mind sharing amongst a couple of you, that would be great. Highlighters, they're just at the very back of the classroom. So if you go straight to the back, you'll see the label on there, highlighters. Yeah. want to change my plan. I don't like making plans at the beginning because I often change my plan before the end. I'll be right with you, okay? I want to make sure that you have the tools to go off this weekend and do what you need to do. Yes? So I'm going to wrap this little activity up. If you haven't quite finished it yet, don't worry, you can finish that for homework and come back next day and show me. Let us go then to the weight and mass video, which is on page 14. Okay, it's a short video, so it won't take very long. If you don't mind going to page 14. And we're going to debrief on this observation inference probably next day, okay? So that we have time to get a little bit done on weight and mass today. So we are going to page 14. Looks like this. Weight versus mass. Okay? Page 14. We're going to go watch a little video from NASA. Oh, I need to turn this on. Pause that. Make it big. Okay.
Hi everyone, my name is Nicole Stott and I'm a flight engineer with Expedition 20 on the International Space Station. And we're here today with you on the International Space Station in the Japanese Laboratory Module.
Hi, I'm Bob Thirsk. I'm also a flight engineer aboard Expedition 20. The topic for today is weight versus mass, a heavy-duty concept.
So what is weight? Weight is the vertical force exerted by a mass as a result of gravity.
Okay, so question number 1. What is the vertical force exerted by a mass as a result of gravity? Weight. Yes.
Weight also means the strength of the gravitational pull on the object. That is, how heavy is it? Weight is dependent on gravity.
What is weight dependent upon? Question number 2. Gravity. Okay.
On Earth, in a 1G environment, an astronaut in his spacesuit would weigh 360 pounds.
Okay, how much does the astronaut weigh on Earth? 360 pounds. Oh my gosh, how much is he going to weigh on the moon? Let's find out.
On the moon, in 1/6 Earth's gravity, the astronaut would weigh 60 pounds. In orbit, he...
Okay, so 60 pounds on the moon. So that's 1/6. If you're good at math, you can do that. If not, I've just told you. And how much do you think he weighs on the International Space Station?
He would weigh 0 pounds,
0
because
pounds.
weight is dependent on gravity, and the effect of Earth's gravity is not observed.
Using more physics and mathematical terms, weight is defined as the force with which a body is attracted to Earth or another celestial body, equal to the product of the object's mass and the acceleration of gravity.
Okay, so what is the equation for gravity? Gravity equals mass and then times acceleration. Now, are you going to need to know that for grade 9? No, but it will be something that comes up for you again in the future. So it's mass times acceleration. That's question 6. Mass times acceleration.
Gravity. So in equation form, gravity equals mass times acceleration due to gravity. On Earth, that's 9.8 meters per second squared.
So that's 9.8 meters per second squared. And if you don't want to write that all out, you can write 9.8 meters per second squared. Those are our abbreviations for meters and seconds. And when we write that slash line there, that's per.
But what is mass? Mass is the property of a body that causes it to have weight in a gravitational field.
Okay, so what's the answer to number 8? What is the property of a body that causes it to have weight? Mass. If it doesn't have any mass, it won't be attracted to the earth. So light, for example, is energy. It doesn't have any mass. It doesn't fall to the earth because it's not made of mass.
The mass of an object is not dependent on gravity.
What is not dependent on gravity? Mass. So if you have a certain amount of matter in your body, does that change if you go to the moon? No. And the amount of matter in your body is your mass. That does not change. You can weigh absolutely nothing on the space station, but you still have the same mass.
Mass is the amount of matter in an object. Bodies with greater mass are accelerated less by the same force.
Okay, we missed number 10. Mass is the amount of matter in an object.
If we use the same force on these two animals, the elephant, which has a greater mass, is affected less than the mouse, which has much less mass.
And what is gravity? Gravity is a force that governs motion throughout the universe.
What's the force that governs motions? Yes, gravity. Excellent.
It holds us to the ground. It keeps the moon and the station in orbit around the Earth, and the Earth in orbit around the sun. It is best described as the attraction between any two masses, most apparent when one mass is very large, like the Earth. The acceleration of an object toward the ground caused by gravity alone near the surface of the Earth is called normal gravity, or 1g. This acceleration is equal to 9.8 meters per second squared.
1g is how much? 9 point. It should be what? It's not 10 meters per second squared. It's 9.8. Yeah. This is number 14. So gravity is best, number 12, gravity is best described as the attraction between two masses. So the reason that I am attracted to the Earth is because the Earth has mass and I have mass. Okay? Near Earth's surface, number 13, normal gravity is called 1g. And 1g is equal to how many meters per second? 9.8. I'm not going to make you memorize that number, okay?
Or 32.2 feet per second squared. If you drop an apple on Earth, it falls at 1g. If an astronaut on the space station drops an apple, it falls too. It just doesn't look like it's falling. That's because they're all falling together. The apple, or the onion, the astronaut, and the space station, all falling together.
Well, what is microgravity? The International Space Station and us astronauts aboard are traveling at approximately 28,000 kilometers per hour.
How fast are they traveling? 28,000 kilometers per hour. That's number 15. That is very, 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 very freaking fast.
Or 17,500 miles per hour. And we're essentially falling around the Earth, creating weightlessness. The weightlessness that is felt in free fall on a ride at an amusement park or on the International Space Station when it circles around the Earth is microgravity. Objects in a state of free fall in orbit are said to be weightless. The object's mass is the same, but their weight would register 0 on a scale. Weight varies depending on if you're on Earth, the Moon, or in orbit. But
your mass
always stays the same. The first thing that Koichi and I'd like to do is demonstrate that we're actually on board the International Space Station and we're in a weightless environment. So let us show you a few little tricks here that'll make that point. I'd like to have an arm wrestle with Koichi. Let's see what happens.
This is great, actually. Okay. Then small.
One of my favorite Japanese sports is sumo wrestling. We're going to try to sumo wrestle.
There's a question for you. Which astronaut has more mass? Which one? The guy on the right or the guy on the left? That one there or that one there? There? There. Okay, let's find out. Oh, they don't tell us. Okay, so it should be the one that has more mass should travel less far. So the guy on the right, probably, I think. Oh, and here they go. Fun and games on the space station.
The somersault.
Okay, Nicole, show us your stuff. Where'd she go? Come back. It's Superwoman.
Ta-da! Okay.
The International Space Station is the largest man-made structure in space. It was built in pieces and then launched into space and assembled in orbit.
Okay. So, homework is page 15 to 19, page 23. And then remember, this one is you're only doing, I know, you're like, oh my God. You have a whole weekend, page 23. That one's just filling in the little charts. There's like 3 of those little charts, okay? 1.1c, you're going to read and you're going to try to do the exercises. We will go over all of this on Monday, okay? This one, I think there's like maybe 10 words for you to define, but you don't have to look them up, remember? Just what you know in your brain right now. Next week, we'll actually look at defining these words. So this is just to activate your brain on those words. See what you remember. 15 all the way to 19. And I promise you, it's not as much as it sounds. I promise. Make sure if you borrowed a highlighter that it goes back, please. Yeah. If you want to get your phone now, you can get your phone. Yep. Yep. And it will also be on Teams. Feel free to take a picture of what the homework is if you like. It's also on Teams if you prefer. Okay? So good.
He quit, no? What about Joey now?
Yeah. No, no. You're just going to answer, you're just going to fill in the definitions of what's in your brain. If you don't know it, don't worry about it.
What is it? What is the cartoon? The cartoon?
Cartoon?
The picture like that.
Yeah. No, no, you'll see it in there. Here, let me show you. Oh, look. You'll be like, do I remember any of these words? You might remember some from last year, you might
Oh, I
not.
described them.
Right, so you're going to describe what they are.
Oh,
Yeah.
hypothesis is not like, I forgot what that means.
That's okay, yeah.
Is it like, okay, I have to come back to it. Oh, what do you assume, right?
Yeah, it's like an educated guess what you think is going to happen.
Yeah.
Yeah, there you go. See, some of it's coming back, right? Yeah.